Block diagram reduction technique. Let us once again see. Here, this G3 and G4 are in parallel. That's why we can add them together. G3 plus G4. Another thing is here
G3
we
plus
cannot
G4
simplify this part because
then
there is a
get
takeaway point that should be moved from here to here.
yesterday I
If we move
got
this,
quickly
what will happen is
G7
G5 has to be
the
divided by
feedback is
G7.
positive, G6
So let
G5 upon G7 G2 that is coming from here. One summing junction is there, G8. That's all. Therefore, G9 equal to. Now this can be simplified. This is equal to G9. G9 equal to G7 1 minus G6 G7. Therefore, this can be written as R of S G1 G3 plus G4 G9 that is cascaded. This is G10 G2 is as such. So where G10 equal to G5 among G7. Now we can move this also. G2 also we are moving away from that. And this can be called as G11. This together, G3 plus G4 multiplied by G9 can be called as G11. G11 equal to G3 plus G4 multiplied by G9. So what we will get is R of S multiplied by G1 G11 G2 by G11. Another one is G7. Both are added together and it is subtracted. Here one more feedback is there, that is G8. Between these two, one feedback is there, that is also positive. Now we can find G13 equal to, this can be called as G13. G13 equal to G1, G11 upon 1 minus G11 G8. G11 upon 1 minus G11 G8, that is G13. If you multiply this G13, okay. Now this diagram becomes, we have to substitute G13. Now what we will get is G1, G13, G13, this is equal to G12. G12 equal to G2 among G11. So now we'll get G12, one feedback, Another feedback is G10, G10. This is negative feedback. So finally, G10 and G12 can be added together. Therefore, we can write R of S equal to G1 plus G13 and G12 plus G10. That's all. Therefore, final transfer function is T of S equal to forward path transfer function upon 1 plus G12 plus G10 multiplied by G1, G13. Now we have to substitute all these values. For that, the first step is G1, G13 equal to, what is G13? G13 is G3 plus G13 is G1, G13 is equal to G11, okay, G11 upon 1 minus G8, G11. That is also equal to G1, G13 equal to what? G13 is G11 upon 1 minus G8, G11. This is 13. Now we can substitute G11 here. G1, G13 equal to G1. G11 is G3 plus G4 multiplied by G9. That is G11 whole divided by 1 minus G8, G3 plus G4 multiplied by G9. That is G11 is substituted now. Now we have to substitute G9. G9 equal to what? G9 equal to G7, G1, G3 plus G4. G9 is G7 upon 1 minus G6, G7 whole divided by 1 minus G8, G3 plus G4. G9 is G7 upon 1 minus G6, G7. So we got G1, G13 like this. If you simplify this, what you will get is these two, 1 minus G6, G7 can be cancelled and it can be multiplied instead of 1. What you will get is G1, G3 plus G4 multiplied by G7 whole divided by, I am going to cancel this part and this part, divided by 1 minus G6, G7 minus G8, G3 plus G4, G3 plus G4 multiplied by G7. So we got G1, G13. The numerator part we got now. The denominator part we have to find. The denominator part is G12 plus, the denominator part is G12 plus G10. That we have to find. G12 plus G10 equal to, G12 equal to what? G12 equal to G2 by G11. G2 by G11 plus G10 equal to G5 by G7. That is equal to G2, G11 equal to G3 plus G4 multiplied by G9 plus G5 by G7. If you simplify this, what you will get is, G2, G7 plus G5, G3 plus G5 sorry, G3 plus G4, G3 plus G4 multiplied by G9, G3 plus G4, G9, G7. This can be substituted in the T of S. If you substitute in T of S, what you will get? We got the numerator and denominator separately. If you substitute that in the G1, G13, in place of that, if you substitute that, this is denominator part. Denominator part. If you substitute that in the transfer function, you will get G1, G3 plus G4, G7. That is, we got for numerator. This is for numerator. That we are substituting. G1, G3 plus G4 multiplied by G7 divided by 1 minus G6, G7 minus G8, G3 plus G4, G7 whole divided by, this is for numerator. This is for numerator. Denominator 1 plus the same numerator we have to write, that is G1, G3 plus G4, G7 whole divided by 1 minus G6, G7 minus G8 multiplied by G3 plus G4 multiplied by G7. This is for numerator. For denominator already we derived, that is G2, G7 plus G5, G3 plus G4 multiplied by G9 divided by G3 plus G4 multiplied by G9, G7. So here we are getting G7 is getting cancelled. G3 plus G4 is getting cancelled. Therefore, this is equal to, now what is this part? The denominator and the numerator and the denominator, part of denominator in the denominator has to be getting cancelled. For cancel that, we are taking LCM. LCM means in place of 1, we have to write this. Therefore, we will get numerator G1, G3 plus G4 multiplied by G7 whole divided by G7 whole divided by, I am writing this in place of 1. 1 minus G6, G7 minus G8 multiplied by G3 plus G4 multiplied by G7. So we are writing for 1 alone plus G1 only there, then G2, G7 plus G5, G3 plus G4 into G9. G9, this G9 and G9, we can cancel this and we can write G9 here. So that G9 can be written here and the G9 can be cancelled. Okay. So numerator is simplified, denominator we have to simplify. So numerator is G1, G3 plus G1, G3, G7 plus G1, G4, G7. That's all. This is numerator. Denominator is we have to find, that is 1 minus G6, G7 minus G8, G3, G7 minus G8, G4, G7 plus G1, G1, G2, G7, G9 plus G1, G5, G3 plus G1, G5, G4. So 9 has to be substituted. That's all. That is the only thing that is not in the G2, G7, G9 here comes. Here divided by G9. This G9 here cancelled, here it is not cancelled. Then what you will get? G1, G5, G3, G1, G5, G3, because G9 getting cancelled. Here, G9 in the denominator. Here, G9 must be in the denominator. That's all. So, G9 in the denominator. This is getting cancelled. Here, not cancelled. Therefore, it should be in the denominator. G1, G2, G7 upon G9. Okay, the denominator can be written as P of S equal to the numerator is G1, G3, G7 plus G4, G7, G4, G1 whole divided by 1 minus G6, G7 minus G3, G7, G8 minus G4, G7, G8 plus G1. I am going to substitute for G9. G9 equal to G7 G2, G7 upon, we'll write on one step here. Otherwise, G5, G3, G1 plus G1, G5, G4. That is what we wrote here. G1, G5, G3, G1, G5, G4. Here G9. So this part, instead of G9, this part is equal to G1, G2, G7 whole divided by G9 equal to G7 upon 1 minus G6, G7. G7 getting cancelled and it becomes the numerator. Therefore, we can write now G1, G3, G7 plus G4, G7, G1 whole divided by 1 minus G6, G7 minus G3, G7, G8 minus G4, G7, G8. G1, G2, G7 and this becomes numerator. 1 minus G6, G7 plus G5, G3, G1 plus G1, G5, G4. Then one more step. G1, G3, G7 plus G4, G7, G1 whole divided by 1 minus G6, G7 minus G3, G7, G8 minus G4, G7, G8. G8 minus G4,
Here plus. Okay. G8 minus G4, G7, G8. This plus G1, G2, G7. Because of this one, we multiplied minus G1, G2, G1, G2 minus G1, G2. G7 is cancelled, you know. That's why this G7 will not come. G1, G2 minus G1, G2, G6, G7 plus G5, G3, G1 plus G1, G5, G4. Now we will convert this into signal flow graph. Node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8, node 9, 10, 11. 11 nodes are there. 1 to 2 is unity. 2 to 3 G1. 3 to 4 again unity. 4 to 5 G3. 5 to 6 again unity. 6 to 7 is what? 6 to 7 is unity. 6 to 7 is again unity. 7 to 8 is G7. 8 to 11 is again unity. Then 9 is below 2. This is, sorry, this direction. Minus 1. Here below 410, below 410. 10 unity. G2. This is G2 plus G2. Then 7. From 7, where is 7? This is 7. 7 to G5. 7 to 9. 7 to 9. Then 8 to 7 plus G6. Then same 8 to 3. 8 to 3. G8 plus G8. That's all. Finished. G4, 10 to 5 is there. 10 to 5. That is G4. That's all. So now, what are the forward paths? P1 equal to G1, G3, G7. G1, G3, G7 plus another forward path is you can come this way. G3 can G6. This is G6. 8 to 7. Not 8 to 7. That is G6. G6. Okay. Now forward path. This is one forward path. G1, G3, G7 plus G1, G4, G7. G1, G4, G7. What is the numerator? G1, G3, G7 and G4, G7.
we immediately we got numerator. So there we struggled like anything to get numerator. Here immediately we got numerator. Only thing is denominator we have to get. Denominator to get what is delta 1, delta 2 we have to find. Delta 1, delta 2 are delta 1 equal to what? Delta 2 equal to what? There is no part of graph which is having loops. Therefore, delta 1 is 1. Delta 2 is 1. Therefore, numerator we got P1 plus P2. This is P1 plus P2. I directly wrote. Because delta 1, delta 2 are 1, 1. So we got the numerator. Denominator, to get denominator, we have to find all loops L1. L1 equal to what? L1 equal to L1 equal to, we can write G3, G7, G3, G7, G8. Can I write? Positive. L2 equal to G6, G7. L2 equal to G6, G7. Am I correct? One more loop I am finding. G3, G7, G8. Instead of G3, I can consider G4 also. Therefore, L3 equal to G4, G7, G8. Can I tell like that? What is the 3, 4, 10? What is this? 3, 4, 10, 5, 6, 7, 8, then come to 3. So that is on closed loop. G4, G7, G4, G7, G8. One more feedback path here. G1, G2, L4. L4 equal to G1, G2. That is minus. Why? Because minus 1 is there. That's why minus. One more feedback. L5. L5 equal to G1, G3. G1, G3. I am following this 2, 3, 4, 7 through G5 I can come. Or G1, G3, I cannot travel this way. I cannot travel this way. Therefore, G1, G3, G7, G1, G3, G7 and G5. That is one more. G5. Any other loop? Any other loop? G1, G1, G3 only. G1, G3, G4. Okay. G1, G4, the same way G1, G4, L6 minus G1, G4. Instead of G3, I can consider G4, G5. So 6 loops I got. 6 loops I got. Any other loop? How many we got there? 9. 8. Yes, 8. So here L1, this loop, what is this? This loop and this loop is non-touching. Therefore, I can say L4 and G7, G6. What is that? L2. L2 equal to minus G1, G2, G6, G7. That is not touching. So G1, G2 we got, G6, G7 we got, G3, G7, G3, G7, G3, G7, G8. Yes, L1 we wrote. G4, G7, that is also G4, G7, G8, G1, G3, G5. We wrote G1, G4, G5. Okay. 1, 2, 3, 4, 5, 6, 7. 2 more we have to get. So G6, G7 we got. Denominator I will write here. 1 minus G6, G7 minus G3, G7, G8 minus G4, G7. This is a block diagram reduction. Block diagram reduction denominator. G4, G7, G8 plus G1, G2 minus G1, G2, G6, G7 plus G1, G5, G3 plus G1, G5, G4 plus G1, G3, G7 plus G4, G1, G7. Here, whatever we got as L1 will tick. G1, G2 we got. G3, G7, G3, G7, G8 we got. G6, G7, that is also we got. G4, G7, G8 we got. G1, G3, G5, that is also we got. G1, G4, G5, that is also we got. G1, G3, G6, G7. G1, G3, G1, G3, G6, G7. G1, G2, G6, G7. Minus G1, G2, G6, G7. That is also we got. Then left out these two. G1, G3, G1, G3, G7, G4, G1, G4, G1, G4, G7. These two are forward paths. That is forward path. Yes, we got all. This I wrote additionally. So we got everything. In single stroke, we got everything. To demonstrate how difficult to get block diagram reduction, that's why this sum. So we got all L1s. These are all we have to put to minus sign. Check the sign. G3, G4, G8, we got positive here. In the block diagram reduction, we got negative. Yes, because in the formula, 1 minus, what is formula? 1 by delta sigma pk delta k, delta equal to 1 minus. Because of that, these are all positive. That's why we are getting minus. That is sign also we are getting correctly. So these are all we get minus. Therefore, delta equal to 1 minus L1. That is G3, G7, G8 plus G6, G7 plus G4, G7, G8 minus G1 minus G1, G2 minus G1, G3, G5 minus G1, G4, G5. That's all. Plus, what is the formula? 1 minus, these are all again plus 2 non-touching loops. That is minus G1, G2, G6, G7. That is in minus only in the block diagram reduction. So we got the correct denominator, block diagram reduction as well as signal flow graph. So this sum is solving by signal flow graph is simple. If you go for block diagram reduction, it is very
time consuming. Time consuming, that's all. Not complex, time consuming, and we should be careful. So this is denominator, this is numerator. In signal flow graph, this is numerator, this is denominator. We got the correct result.